started?
You're going.
Okay, so good morning and welcome to the concept. Today I'm going to be showing you how to load up the probe and enter it into the vacuum system of our magnetic sector electron impact ionization mass spectrometer. So the first thing is, where are we going to put the sample? And we put the sample into these very, very small capillaries that I have cut from capillaries that you just very simply buy from the stores. Okay.
Show me that again. The camera guy was not with it. There we go.
So we get those Pyrex capillaries, and then I use a glass cutter to cut them to a length that allows them to just protrude out of this custom-made probe that Sandra has made for us.
Which is not even an official probe. The official probe would have heaters and cooling lines and all that shit. This guy has nothing. The only thing it has is the peak insulator there for the 5 kilovolts or 8 kilovolts in the source, that's all.
Now you can enter your solid sample just by shaking a little bit into the end of the tube there, or what I prefer to do is to take my sample. Here's one here. This is a nice one because it's orange. Most organic molecules are powders and they're white, but this one's orange, so we'll be able to see it. And so what I'm going to do is I'm going to dissolve it in a little bit of ethyl acetate, which I have in a pot here. So I'm using a GCMS needle, 10 microliters, and I'm just going to suck up a little bit of ethyl acetate, which I deposit into the tube. That dissolves my sample by shaking it around, and I can suck this up. And then right at the end of my capillary, I can put a little tiny bit inside the capillary. It's orange so you can see it. And a little bit around the outside. And then I wait for the ethyl acetate to evaporate. Cleaning my needle because I don't want to cross-contaminate samples.
Aw, why not?
People don't like it. So now just waiting for the ethyl acetate to evaporate away most of it. And now I'm going to break the vacuum system. So there are two sections to doing this. One is the probe inlet here, and then you have the actual source, and there is a gate between the high vacuum area and the roughing pump vacuum area here. So to break that vacuum, I need to turn off the roughing pump, because if I just pull the tube out, the poor roughing pump is going to try and suck air out of the whole lab. We don't want that. So I'm going to turn off the vacuum pump for now and open up this source part. Okay. Again, this is still protected. The gate has not been opened. I now feed this very carefully into here, and Sandra has set it up so that I can't push it all the way and bash onto this gate valve, and equally when I pull it out I can't do the same thing. So once I've got it in here, I now need to vacate this section using the roughing pump. So now I can turn it on, and down here this is my roughing pump gauge. I want to keep my eye on that and wait until it stops pumping down. So that's about 10 to the minus 2. That's kind of good enough. We'll keep going a little bit more. So now the contrast between here and here is lessened. I'm not at atmosphere opening up the gate valve. I won't break the ion gauge. I will not break the filament on my source. So now I'm going to very carefully open up by keeping an eye on this gauge at the same time. I do not want this to get up to 10 to the minus 4, because that's going to break the ion gauge. So very carefully open it, and with very volatile samples you need to be careful because they will already be in the gas phase. It's just very carefully keeping my eye on that, and you get to the point where it won't go up anymore and you can actually open the gate valve up completely. Okay. Now at this stage I want to start the electronics recording data, and so over here on the computer software I'm just going to press go, and it will immediately, I've already calibrated, everything is good, and now I come back here. If Sandra will just put the camera there.
Let's see if we can see something here.
You can look in the window and you can see the filament inside of the source block.
Let's see, where is your...
You might not be able to see it on the camera, but you can with your
well,
eye.
it's kind of fuzzy, but you can see something. Now, if I push this in. Let's see if we can see the probe at some point. Can we see the probe? Let me have a look.
Now there is no stopper to stop you going too far, so you need to keep an eye. You do not want to hit the probe against the source. You want
there it is.
the capillary to sit just on the outside.
It's hard to see, but I can see the probe there. Oh yeah, and the tube. So the tube is a little bit away from the source right now.
So you're going to use the temperature of the source to heat the probe. And it depends on how volatile your material is that you're testing. Depends on what temperature you'd have the source at and how close you get. So we keep an eye on the monitor here. You can see I've got like a baseline there, little tabs showing.
Oh, there's our stuff, 240.
Okay.
There it is.
So that's a perfect. I don't want to go any further in. Now if we go over here and look at the data, you can see our molecular iron here and some fragments there.
Okay, what's it supposed to have? Yeah. 241. Let's see what's going on in here. He says it is 240.12. 240. We got 241.
So let me just have a look at the exceptions.
Oh, he's got nitrogen 15 in
He
it.
has, which is why it's an even number and not an odd number with one nitrogen.
Yeah.
So I've already done this sample. And when I'm happy I've got enough data for the analysis to get the accurate mass on it, I really hope to get at least 2 or 3 scans at high resolution with good reference peaks to be able to get below the 3 millimass unit criteria.
Yeah, so what are the rules for accurate mass?
So they told me recently for the organic guys it needs to be less than 3 millimass units. So I always make sure I give them less than 3 millimass.
Does it matter how high the signal is?
They want to have more than 1%. Okay. So that can be tricky with your organometallics. So once it's all stopped, again, the taking it out is just as difficult as the putting it in. Again, Sander has got me a stopper, so I can't pull the whole damn thing out and vent it, which would be a disaster. You only ever do that once, and then you don't ever want to do that again.
So at this point, when it's dark, you close this.
We close the gate valve first.
Right.
Now we turn off the roughing pump again.
Now we can pull the thing out.
We can pull the probe out.
And as we have pulled it out, the pressure in the source has gone down a little bit. Alright.
Now we put the stopper in. Again, this is all at atmosphere now. Put the stopper in and we leave it pumping down so we don't get moisture and stuff.
That's it. Now we should clarify some things. So this instrument was made by Kratos Analytical, and it is called a concept. And the only original thing left is this kind of two-part. The electronics has all been changed over the years. And an old data system on it, run on a Spark Station 5 with 2 monitors. This is before Bill Gates started out.
It's beautiful.
Yeah. Okay, that's it. That's all then.
Thank you.
Stop.